We're going to look at graphing inequalities. Whenever you graph an inequality, you're going to do the same thing as if you would as if it was an equation. So when we graph an equation, we want to always try and keep in mind that y equals mx plus b, that slope-intercept form. That's our go-to for directions as to what we're doing here. So let's start that. What is our b value? Here, it's a 3. Find your y-axis, find 3 on it. I then move and use my slope, m. In this case, we have 1/2. Let's remember that rise over run. I want to rise 1, I want to run 2. So we go up 1, we go over 2 spots. I can also do this in the reverse. If I go up 1 and over 2, I can also go down 1 and back 2. As long as I do opposites, I'm okay. Now, when we first dealt with inequalities, we had an open circle or a closed circle. We don't have circles now, we're going to have lines. We're either going to have a solid line or a dashed line. There's no equal sign, so if there's no equal sign, we'd have an open circle, but in this case, an open line or a dashed line. So there's one of the differences between graphing a line and an inequality. Now there's one other change. When we do this, I need to shade either to this top left or the bottom right. How do I do that? Well, I pick a point and I shade. Well, I'm going to pick 0, 0 here. 0, 0, that corner. I like it because it's nice. It's in a nice spot. I like using zeros. Things cancel out, especially when we have fractions. Let's see what happens here. I want to take this coordinate. Remember, that's x and y. I want to take them and I want to substitute them back into the problem. So I'm going to rewrite this. We're going to plug a 0 in for y, 1/2 times 0 plus 3. Now let's multiply and let's see what our problem tells us at the very end. We've got 0 greater than, cancels out, 3. Is 0 bigger than 3? Is this statement true? No, 0 is never bigger than 3. That's false. Now, that means this point, that's what we plugged in, that's false. You have two options here. You have true, false, you have right, wrong, you have on, off, you have in, out. It doesn't matter. If I told you that this problem was wrong, if I picked another point on the other side of this line, it's got to be right. So what do I do here? If this definitely isn't the answer, every coordinate now on this upper left-hand portion has to be a solution because everything over here is going to be wrong because that says it's wrong. Let's try another one. This is not in slope-intercept form. It's currently in standard. I need to make this look like that before I do anything. So let's solve for y. Minus 3x. When I do this, I want to make sure my x comes before that 2, just because we want to keep that format there. Y is not alone. We still got that negative. Take care of that negative. We're going to divide everything by -1. And when we do that, all of our signs change. But what else happens when you divide by a negative? When you multiply or divide by a negative, our inequality sign has to flip. So let's rewrite it the other way. Now our problem looks just like slope-intercept form. Now I can do this. I can graph. Start off with our y-intercept, our b, -2. Find the y-axis, find -2 on that axis. We need to move using our slope. That slope's always rise over run. We only have one number. Let's turn that one number into two numbers. Do it by turning it into a fraction. The fraction that we use is that number 3 over 1. When you plug 1 under any number, it doesn't change the value of it, just changes the way it looks. And in this case, it helps us move those two different directions. So now I have a rise. I can go up 3 spots. 1, 2, 3. I can run 1. Okay. Will this be a solid or a dashed line? We see an equal sign. That means it's got to be solid. Let's connect it with one big solid line. Almost done. The inequality also says we have to shade. We have to pick a point, any point. Let's shade. So in this case, I'm going to pick 2 points. And let me change colors. I want to pick 2 points. I'm going to take 0, 0, and how about over here, which is 2, negative 2. Let's see what happens when I plug both of these back into this problem. Now I'm going to get rid of our last check. I want to take 0, 0, and I could plug it back into the original or our new one. I'm going to go back to the original. So 3 times 0 minus 0 greater than 2. And let's do it one more time down here. We're going to say 3 times my x value is positive 2 minus my y value is negative 2. We'll fix that in a second. 2. Okay, up top, 0 minus 0 gives us 0. Is 0 bigger than 2? No, that doesn't make sense. If that doesn't make sense, that means this doesn't make sense. Let's try the next one. 3 and 2, 6. A negative negative is going to give us a positive 2. And is 8 bigger than 2? Is it equal to 2? It's definitely bigger. I like this. That makes sense. So when I come back over here, I know that this is true. Now think about what we just did. We have a line. It divides our graph into 2 parts. This coordinate was wrong. This coordinate was right. Everything over here does not work. Everything down here will be a solution. My solutions are going to be everything colored in and that purple line. My solutions over here, everything colored in, but not on the line, because that line, it's everything creeping up to it. It's never touching it. Remember that open circle? We never touch it. It's never the answer. That's graphing inequalities.